Okay, the last two trends we're going to look at are electron affinity and metallic character. Electron affinity is the energy change that occurs when an electron is added. So I'm forming a negative ion. So it's kind of the opposite of ionization energy. One key difference is that ionization energy is always positive. It always requires energy to remove electrons and form positive ions. However, the same is not always true for forming negative ions. Sometimes energy is released when negative ions are formed. That means I'd have a negative electron affinity, which means that I'm more likely to form a negative ion. Nonmetals generally have more affinity for electrons than metals do. So as I go from left to right across the periodic table, electron affinity goes up because my nonmetals are on the right side and my metals are on the left. Electron affinity is also more negative toward the top of the periodic table. Those smaller elements are more likely to form negative ions than the larger elements, and that's because that small radius allows the nucleus to hold those electrons, extra electrons in. So those very large radii make it harder for the nucleus to hold on to one more electron to make it a negative ion. Metallic character talks about exactly what it says. How metallic does this element act? So as we look at the periodic table, the most metallic elements are down here. They're the ones that form positive ions the easiest. They're the ones that are hardest to turn into negative ions. So the closer to the bottom left of the periodic table we get, the more metallic element acts. So, likewise, if I have nonmetals, the most non-metal-like atoms are up here. And a lot of times we don't worry about the noble gases because they don't really react or do anything. So we're really talking about up here. These are the things that are most likely to form negative ions. These are the things that are most likely to react with metals. These are the things that are most likely to react with nonmetals. So that's looking at metallic and non-metallic character. Hey, we also have something called metalloids. So as we go from left to right across the periodic table, we get increasing non-metallic character and decreasing metallic character. So at some point we consider that the elements, there's a crossover between what we call a metal and what we call a non-metal, and that's indicated by the staircase. So these things that touch the staircase, not so much aluminum, but silicon and germanium and arsenic, we consider those, a lot of those things, metalloids because they have properties that are both metallic and non-metallic. Because it isn't a switch, oh, I have a metal, I'm a non-metal. It's more of a gradual change as we go across. So that's why we have things called metalloids. So, in summary, if we look at highest atomic radius is down here. So atomic radius increases down the group and decreases across a period. Ionization energy goes up as we go across a period. So if I look at these arrows, highest ionization energy is over here, or actually over here. So highest ionization energy up here. So ionization energy goes down as we go down the group. Electron affinities up here, non-metallic character up here, metallic character down there. So the only other trend we'll really look at is electronegativity, but we will spend time in class looking at some of the exceptions to trends and why those exceptions exist. And those exceptions exist because of the electron arrangement.